All right, welcome to Stormz Tech Corner, the Dungeon Crawler Network podcast on all things technical and gaming. We can make it up as we go. I'm Stormzlord, co-guild master at DCN Guilds, Hands of Fate and ESO, council member of the Hands of Fate Guild and Ashes of Creation, and all-around technical guy. Um, my technical cred is I've been coding since I was 12, many multiple languages, and have fun all the time. So, let's look at what we're going to look at for this first podcast of Stormz Tech Corner. Game engines. Well, what are they? What do they do? So basically, if you think about it, game engines are a framework that provides structure and default building blocks for building games. So behind me, you'll see a huge vista of seen inside Unity, which is one of the premier game engines currently out there for 3D gaming. They're also making a push into 2D gaming as well, which we'll talk about. To give you a quick preview, currently what I have loaded up is the Unity framework, which includes the editor. The editor itself is part of the framework. Uh, some code can actually operate on the framework as well as within the game itself, depending what needs to be done. So let's look at what we got. First of all, you see it's an editor. Pretty simple, huh? So there's a hierarchy of all the objects in a particular scene. In this case, it's a demo level put out by a mana station called the Antiquated Temple, which I'll have to edit out this piece and figure out how to say that. But the temple here, if you see it now, is not running. You simply see the camera. Some pieces over here that I have ready for showing. If you see these white dots, that's currently where flame is. If you press the build and run, which is what that arrow is, it compiles the code, which we'll talk about later, and then presents it from the current camera. The current camera has no way to change, no way to move. We'll talk about that later. But you see then it's a nice uh, vista that is color. It has not been post-processed yet. It has depth to it. It has the ability to show movement. If you notice, the flames are flickering in the background. Currently, the trees are not moving. There are no current atmospheric effects in this particular setup, but they could be. So, all right, so we'll put that on hold. Go back to what is a game engine, which makes time and lesson charts about. All right, so game engines are a software framework. They're a layer that is meant to be built upon. It's a framework that's meant to be uh, added to, as well as taken from and added different things in its place. So the GameWork is a framework. GameWork, that's a good word too. They can provide features like animation. We saw the flames flickering. They can provide artificial intelligence, which they do. You can provide rendering of graphics, collision detection, memory management, all this different stuff. And at the bottom of this week's podcast, I'll have a list of all the links where this is referenced in case y'all want to look it up. That's fine too, because I'm not trying to tell you exactly how things are because I know everything, but I'm trying to tell you things as they are because I'm able to research and look and find things as well. All right, so we're back to a game engine. A game engine has five, let's call them mini engines or pieces inside them. These five components are the main game program, which is really hard. It's just the framework that runs. In this case, with Unity, it's the editor and the main code that opens scenes, things like that. Um, but even portions of that are replaceable. There's a rendering engine, which you can use 3D graphics that comes with Unity, but you can replace it. Audio engine, which consists of the algorithms for sounds, playing sounds, stopping sounds, making sound attributes different. Again, that's the audio engine portion of it. There's a physics engine, right, that allows for physical implementation of these laws within the system. And they can be somewhat cartoony, they can be ultra realistic, depending on what the need is. Again, these are replaceable components. There's also artificial intelligence. There are modules within game frameworks that are there for artificial intelligence. And I that's really artificial intelligence when it comes to gaming is more of a misnomer. Most of the time, artificial intelligence is a pre-factored or pre-thought out process or tree that the artificial NPC or whatever is artificial will follow that intelligence in the tree. That's not truly artificial intelligence. We can talk about that later some other time. But again, it's all modules. The one thing about modules and one thing I enjoy about modules is they're interchangeable with each other, particular pieces of it. Within Unity, slip back to Unity, you'll see that the game structure itself, there is what's called an asset store. Now, you can either get free assets, you can buy assets on sale. You can see there's a big sale going on this week. I have bought 150 plus objects in my course of a year and a half of building mobile games as well as building a couple dungeon crawlers which I've not finished and a space simulation asteroid type game which again I've not finished. I also have some AR within Unity. Um, so you can buy these assets that help you to jump forward, or there's assets like this particular one here, this console enhanced. This is the free version of it. While I evaluate it, it allows us to go to the console, which is basically the output from the code, and we can do different things with it. It's a more verbose version, a better articulated version of the console than the one that exists with Unity. Now this is Unity. Again, you can use Unreal 4, which I've used. There's a whole host of other engines. Um, one of the links at the bottom is a list of game engines. You'll see that they are high-level languages. They are usually in C++ or Java, C Sharp, Basic. That's much Basic. Java, they're pretty again higher level languages. In other words, they're not low level languages. They're not assembly. They're not things like that. They're going to be higher level languages that are easier for people to understand and work with. And then they're compiled or interpreted, a later discussion for that, so that they run faster on a machine. And that's the purpose behind that. Again, if you think about it, well, I do, but not everybody does. Java programs, for instance, are not compiled. They're compiled into bytecode. Um, this bytecode is executed within a Java virtual machine at runtime. Um, and this Java compiler is what puts it into that. But again, Java itself is more readable. It allows people to then work with it at a higher level and then compile into this bytecode. C++ works the same way. C Sharp works the same way. .NET, Visual Basic, Basic, all high-level languages compile or interpret into a lower level bytecode that is then run. All right, now that could be a large tangent. We're not going to get into that right now. Let's see. So, let's talk about it. Graphics, right? Game engines, graphics. Of course, we have graphics in the game engines. If you look at that, this particular one, you have all these graphics. If you look down here, you see a list of all these different things, all different pieces you can select. Now, what you see is on the right-hand side is an inspector. That basically it shows you the properties of that particular object. Within that, there are other objects. Mesh renderers, scripts, colliders, all that sort of stuff. And then each particular game object in the left has properties that appear on the right in the inspector. So these particular pieces are, they're assets. You may think, hey, this is easy, and it is, but you can take these and work with them, change the properties, make them behave differently, and it's easier than coding this every single time, right? So you have a particular, broken railing that you want to focus on, and you've got this built. You can then replicate it multiple times. If we take, for instance, if we're going to go into this scene, we'll pop over here. We see the camera. We over here want to scroll in. And you see that we have this particular pedestal, which I'll pick any pedestal. And it then dropped into a collision first. I don't want to do that. Notice there are boxes within each other one. See, this collider is up here. It's set up to collide, right? It's what colliders are. They collide with each other. When you hear hitboxes within a game, they're really colliders. Where things collide, they can then know where they touch. Let's pick another one. The barrel. Hey, look at that. It's a barrel. The barrel has its own collider, not within a mesh, so we don't have to mess with it right now. So this barrel, if we cycle in, you'll notice when you've clicked within the scene, you see the specific pieces of it. The game is still looking over here. That's the game from the camera's point of view, which you either attach to a person or you move freely, whatever you want to do. But again, within these game engines, in this case Unity, you take the object, you highlight it so you see the barrel. Here's the barrel. There's the barrel in the hierarchy, and here's the properties on the right. You can name it what you want. You can put it in a particular layer. You can change the collider, right? So if we take this and I want the size to be larger, we scroll this all out in, right? However you want it to be. Uh, Typical discussions about how they work later. We can talk more in depth, but you just change the size of the collider or the hitbox, and that's where they touch. You also have this particular piece where you can then change the direction of the object, right? Now think about it. When you had these barrels in Donkey Kong, way back when in the 80s, each particular sprite had to be drawn on the screen. You had to tell it where to go. If you used logo in the past, same thing. You tell each particular sprite where to go. In this case, in this high level game engine, I'm not telling each particular one where to go. I'm using the tool to tell it what to happen. In this case, we're just monkeying around the barrel, huh? No pun intended. And then we have that, right? If you look at this barrel, another barrel is happening around sideways. It's got its own collider. We can put it in any direction we want. You have to make it look nice, right? Because if you look here, it's intersecting. When you see it in the game, you'll see that. But the point is, you have these objects that can be large objects, right? You can have both barrels together. All of a sudden, you have a group of barrels. You can then select it and do things with you want. If you look over here on the side, you'll notice that a couple of these properties are dashed out. That means the two different barrels have two different properties, so it can't show you. But if you notice, the scale is the same. They're all one. Change it to 2, and all of a sudden you got mega barrels, right? So you have this. If we were to start the game, you'd be able to look over and see these mega barrels sitting there, which we didn't do, so that's fine. But this is all what an engine is about. An engine is an editor that allows you to go in and look at it. It allows you to do different things with it. Now, within this engine, like we said, there are different parts. Unity itself has the ability to do sound, right? There are sound things in there. If you were to go to the asset store, you'd find one for sounds as well. Here's a particular one. It's not sound. It's a simple particle scaler. It's one I had purchased. By the way, not paying me anything, but it's a good piece of software. Works for Unity. What it does, if you're using particles in either a 3D or a 2D game, it allows you to scale all the particles in a system or particle system at one time. That will allow it to get larger or smaller based on your needs. Again, not a huge part, but if you think about it, that's what engines are for. And this is just one particular part. This is the particle system or the particle engine. If you look at Unity, again, we'll focus on Unity. I think the next time I do this, we'll do this on Unreal so I can see how that works as well, because I've used both. But we have objects, cubes, spheres, capsules, right? All this stuff. You have ragdoll physics, you have 3D text, terrain, wind, blah, blah, blah. All this stuff, right, is what an engine's about. If you look at Unreal 4, if you look at Game Maker, if you look at Hero Engine, same thing. They have the ability to take an object, move it around at whatever size it is, whether it's a barrel, whether it's at one particle, whether it's a whole uh, village, like say if we decide we want to go ahead and we want everything here, right? Here's our particular demo. If we look at that, if we unselect the barrels, if we go up, we select everything. Oops, wrong button. We have to use the right button. It selects everything. So you have up, well, that didn't do it either. It allows you to go in and see, okay, there it is. Everything is selected. So if we decide we want to move this, and I'll put it back before we're done, uh, it moves it. Now you see some in the background, you see some waving orange lines. Those orange lines show you where particles are. So some of this demo are particles, flames, and water. And that's, again, just part of the system, is it shows you that. Now, if we want to have a different particle, right, we could pause these particles, or we don't have to. Um, we can bring in those different particles. Now, particles are a use of the engine. If I take an Unreal particle system, a particle effect, I can't go in and, that's my dog, by the way, which you probably hear in the background, one of them. You can't take that particle system from an Unreal 4 object and bring it over to a Unity or Game Maker or whatever engine you want to use. All right, back to the game engines themselves. So if we have a list of game engines, which is again is the link below, you'll see there's Build Engine, C4 Engine, Chrome Engine. Excuse me, IBM has built their own engine. We have the the Creation Engine, which was proprietary, built by Bethesda, so it's not something you can get, not something you can use. But it was built on another engine, which we'll talk later when we look at different engines more in depth. There's the Cry engine, right? Far Cry's, they're built on their engine. It with an engine, it comes down to what do you want to do with your game? Do you want to start from scratch? Do you want to start from an engine and then replace pieces of it? For instance, if you look at ESO, look at their game credits, and then we'll do a technical review of Elder Scrolls Online or ESO later. But if you look at the bottom of their game credits, you'll see they list the software that is used. Why there is let's say, an internet hubbub about which engine was used with Elder Scrolls Online, I don't know. Um, I know they list in the credits what they use. People just don't want to believe that, but they do. Uh, ESO is powered in base by the Hero engine. Now, the Hero engine's been around for a while. It gets bad reviews. It gets some good reviews. Really, it's sort of falling out of favor. It's still moving forward. I don't see it being used as much. But things like SpeedTree come with this engine. SpeedTree was used very heavily in Morrowind, the Elder Scrolls 3 Morrowind, not the Elder Scrolls Online expansion of Morrowind, but they do use that in parts. SpeedTree is basically, and we'll talk about this later, is a component of the animation system that is simply with trees and vegetation, right? So Morrowind and somewhat in Elder Scrolls Online, they've replaced the portion of the animation system for those two games with SpeedTree, particularly for trees and vegetation. So this is the neat part. You can take an engine and you can decide, I love this whole engine. I'm just going to use it. Anything else beyond that, I'm going to build. And that's fine. That's one way to approach it. I approach it a little differently. I approach it from the build versus buy. Do I have time to build all this stuff, or can I take something off the shelf? We'll call it a COTS product, right? Commercial off the shelf product. We'll pull it in. We'll integrate it with the engine, or do I want to build it myself? Well, it depends how much time you have, right? How many resources do you have that are going to be able to go in and build something from scratch? Or, well, let's license it and use this, right? Let's take a hold of that. And both, all the engines, well, let's say all, most of the major engines allow you to have these little markets that allow you to sell your own assets or blueprints or whatever you want to call it, or that people then can use in their own games to go forward. Um, what's really interesting again is everybody seemed to follow this process for these non-proprietary engines. Now, some game companies like to consider their game engine proprietary. They are not going to sell you the engine. They are not going to give away the engine. They're not going to give it to anybody. Take the creation engine within Elder Scrolls and Bethesda. They're going to keep that one. Now, Unity was started, and it is a not open source, but it's an engine you can get, right? An engine you can use. Uh, Unreal 4 originally was not an open engine. It was not an engine that you could get. It is now, right? Unreal 4, um, and there's again hundreds and hundreds of engines that have been put together through the years. Unreal 4 is again C++ based. You can use the Unreal script, you can use C++, you can use blueprints. It's cross-platform, right? Um, and Unity is the same way, right? Unity is cross-platform. It goes 3D. They've really pushing the 2D lately. You can do C++, you can do C Sharp, you can do JavaScript. Personally, I use um, C Sharp within my Unity code. Let's see what else we're going to talk about. We're going to talk about more about game engines. So, we talked about the graphics, the 5 components: graphics, logics, physics, AI, which misnomer, networking, optimization. Networking, another good idea, right? Networking, your net code in the back end. There is a set of net code that you can use within Unity. It has its benefits, it has its pitfalls, just like every other engine and its net code. In this case, you could use Photon. You could use another asset that you can pull in to do that. You could also do visual scripting in a large portion of these available game engines for people to work on at a smaller business level as opposed to, the huge companies. They allow you to bring in these assets, and they're just components. That's all they are. If I want to replace the physics engine, for say, right? So the physics engine, what is that? Well, if you think about it, a physics engine is just the computer code software that provides the approximate simulation of physical systems, rigid body dynamics, collisions, right, for colliders, soft body dynamics, fluid dynamics, all this within um, again games, and now they're using it in films, right? Pixar and different, and even other films, Avatar and things like that. They're using these different things. Now you either have, again, there's pretty too much classes of physics engines: real time and high precision. High precision engines require more processing power, very precise physics, right? NASA, SpaceX, they're going to use extreme precision physics, computer animated movies as well, extremely precise engines. Um, the other class is pretty much real time, right? They're real time physics. They depend on the speed of the processor and the gameplay. It's a simulation of physics. It's close. It's not going to be an exact, unless you want it to be, but that's a little bit of work, right? An example, a particular game that somebody had played. I won't say what it is just yet, but they were using a bow and arrow, and well, in this case, a crossbow, and they would try to lead the other character when they're going to shoot them in the PvP. But because this particular physics engine had not been set up to allow for the wind drop or the speed of the arrow or the speed of the body moving, when you fired it, it was an automatic hit, right? That just talks about the way those two collision boxes work. And again, we can look at more in depth than that, but we don't need to. Not right now. We can do that later. But again, you have these real-time physics and precise physics. There's 2 different types. Again, which one do you like? Depends what you're doing. Video games, real-time physics are fine, right? It's a simulation. It's perceptually correct. It's not exactly correct the way it would behave. It's an approximation, right? Now, this game engine portion, the physics engine, can be taken out and replaced because it's just a part of a framework. In the case of ESO, they use the Havix physics engine. Um, that was one of the choices they made. Other games make other choices based on what they want to do. They want a particular engine is better for the physics piece, but maybe not the animation piece. Or maybe it's better for the graphics piece, but it's not better for the people coding it. It's harder to code because it's not in C++ or C Sharp or whatever. So it depends. When you sit down and decide what game engine you want to use, it's not a simple yes or no answer. There's a really a large number of factors that you have to work through. You decide whether you want to, first of all, do you want to build your own physics, your own engine? Have at it. It's going to take you years, but go at it if that's what you want to do, right? Or you can also license this engines into Unity, or you license Unreal 4, or you use it, whatever you want to do. In certain license levels, you can have the actual code in the engine, and you can tweak it if you want to. Because you don't have to do exactly the way you want to. It's up to you. It is, again, a more of an art than a science at sometimes, and more of a science than an art. It's going to depend how you feel. So this physics engine in ESO, it's Havoc, right? Like I said, also SpeedTree. SpeedTree is not a physics engine; it's an animation engine. It does realistic trees and vegetation. Again, it was a choice. Which would we rather use? But if you notice, in Morrowind, it was used almost exclusively. Only partially so in ESO. It depends. We don't know what parts, but part of the credits is they tell you what they use. So what I like to do in my fun time is when I take a game and I like to play it and I'm going to review it or not, I want to understand what engine it used, what pieces did it replace, and things like that. All right, so now if we look back at Unity, which we'll come back to, and you've been staring at a web screen for a while, what I'll do is I'll show you the code or the framework, another object. How's that? So within this temple, which is my game built on the Unity game engine, there is a framework called Orc. All right, so Orc is an asset that's available in the Unity engine that I purchased, and it's this current one is deprecated. I'll be purchasing the next version, but I'm using it within my game because I realized I wanted to create an RPG. So I've started doing that. And I'm looking into it going, there's a bucket load of programming for one person to do. So I started looking out on the asset store. And there is this framework called Orc Framework, a terrific framework. It allows you to build a game. It has the typical RPG um, things you'd expect. It is combatants, it has battle systems, it has inventory, it has stamina, it has health, it has magic, it has control of the characters, it has camera control. Um, but like Unity itself, it allows other pieces to be plugged in, which is tremendous. Because while I really do like Orc, I'm not totally thrilled with its character controller, at least this version. I haven't checked out the newer version. So what I've done is in this particular one, I used another product, um, a third-party controller, or third-person controller that also does first-person controller, and I replaced or in this particular version of Orc, you can say don't use our own controls, use these controls. So I replaced it in there. So I took part of their framework out and connected it in another framework that was pre-integrated, so I didn't have to work too hard at it. And that's the interesting thing about how all this works. They can either be pre-integrated or not. So we'll talk about that at another time. We're already at 30-minute point. We've talked about game engines, physics engine, the networking, the AI, which I want to spend at least an hour talking about AI, but not right now. Again, these things can be swapped in and out. It's like building a house and you decide, you know what, I don't like the Formica counters. I want to have granite counters, or I want to have stainless steel counters. You just take it out and put it in, right? Now, within game engine, may have to have some coding to do that. Just like when you're replacing the counter, you have to decide the fasteners are different for a mica counter than a granite counter. And that's how you figure all these things out. So if you look at the different engines, you have the Hero engine, right? You have the Unity engine, you have the Unreal engine, uh, bucket load of other engines. IBM has their own engine, right? Um, and they all can be used to build different types of games. In this particular part, this Unity engine was originally a 3D engine, right? Because look at this, it does phenomenal 3D. Um, some people look at Unreal and they believe that Unreal does a better job of animation. And that's true in some cases. If you decide you don't want to use the animation within Unity, you can always plug in something different if you want to. Same thing with Unreal. You want more of a cartoony look than a real look. You can do that in Unreal, even though its base is to look real. You can swap those in and out. And no matter what game you have on the market now, it was built on one engine or another, or pieces of an engine. Um, you don't start games from scratch anymore. It's like programming for any application. You don't program the window. You don't program the button. You drag a button onto a window and a framework that builds it for you. In Java, you don't start and say, "Hey, build this button. It's this wide, this many pixels tall, and this is the name on it." You drag and drop things in, you move them around, and it's like playing with blocks. Same thing with these engines. In this case, this is 3D engine. What I will do is I will change to another project that we have. Well, we have a bunch of projects, but in this case, we have a 2D project. I'm not going to save these changes. We have a 2D project that we're working on for Unity, a contest, and it's a 2D platformer. Again, there are no games. I would be honestly shocked if any game was written from scratch anymore. There's just so much power in using an engine of any type of engine. I don't know why we would do that. So now that my OBS is showing a black screen because Unity is gone, I'm bringing up another version of Unity or another project within Unity, so it'll come up in a minute. We've looked at a game engine. We looked at the five major components. We've looked at it. It's basically a framework that you can plug and play whatever you want. It comes plugged together, so it's helpful to start, but you don't have to stick with it. You can move to whatever you want. And that's the beauty of it. In this same engine, and Unity and Unreal are the same way, and any other ones, I've started 3D games, and I've also started mobile games, and I've written them and created them and integrated them. We also have 2D games over here. In this case, Human After All, a game my son is writing, or at least he's doing the story to it. And if you look at the scene, um, it looks significantly different than the original version of the scene. Um, there is within Unity another, we'll call it quote unquote engine, a 2D engine called Corgi, terrific tool for 2D platformers. And that's what I used the basis of this on. We are doing this, we're taking a particular demo they had and we're using it and we're stretching it and changing it and we're turning it into our own game, right? So we're not starting from scratch. There's no reason to start from scratch anymore. I mean, you can if you want to learn every single thing, but you got to learn what you want to focus on. Now, for instance, if I was to take this hell background and I turn it off, right, you'll see there's the platforms. You still have some stuff. If you take the foreground, I was working on a few different foregrounds, and take it, you see here's the basic platforms. You'll see there's some basic ladders, some different things like that. Now, if you go to, where's my other level? I have originally started out making this a laboratory. Um, and I want it to look like uh, a laboratory. Let's see if this is it. I don't think this is it. No, this is the apocalyptic, which I can't say that word, background that I thought might work. Didn't really do. Notice the engine itself, the platform, it's all the same, right? Whether it's rotators, whether it's treadmills, whether it's platforms, water, kill on touch, like the blades, transporters, teleporters, all that, that all works the same. So I'm changing in the engine what I'm using for a background, right? And that can completely change what's going on. If you look at there, here's the lab. All right, see, look at that. Completely different, right? Totally different viewpoint. Platforms are the same, looks different, right? This is what a 2D engine can do. And if we were to start this one, let it pick up a little bit. It's got to compile all the scripts. Um, there we have, right? A completely different game, a 2D based game that you have. And there are word games, like I said, there's mobile games, there's you name it, Scrabble, Match 3, all this sort of stuff. It's out there, these game engines can do. And if you think about it, you can do it. So you too can program whatever you want. But it's a matter of how you want to do it. Do you want to start from scratch? And I've done that too. I've started back a long, long time ago using BASIC from scratch, where we had to do from scratch how to do it. Same thing when I started C++. When I started C++, you drew each button. You had to figure out once you, well, why am I doing this? When I draw a button, I would then say, hey, let's just copy this code, or you know what, let's make an object so I don't have to copy the code. Same thing here. These engines, most of them, are object engines. They're oriented for objects, and that's the way they work. All right, so I'm probably way off on a tangent, and I tend to do that. So these technical corners can get very interesting. Hopefully, we'll have some guests on to stop me from going off in tangents everywhere. But for now, we're going to say that this has been a great time. It's been a first look at all things technical in Stormz Tech Corner and look at the Unity game engine. Next time, we'll look at other game engines as we look into other games. A technical review of ESO is coming up. A technical review of other games are coming up. A technical review of how to do different things. Whatever technical things we want to do, there we go. Again, this is Storm's Technical Corner. We are a podcast in the Dungeon Crawler Network. Um, I, Stormzlord, welcome you to come send questions, send mail. You can reach me at stormzlord@twitter.com. You can reach me at stormzlord at digitalpiperstudios.com. You can reach me in the Dungeon Crawler Network Discord. Anytime you want, reach out to me. Send me ideas of what you want to do for the next podcast. Next week I'll be back. Not sure what we're going to talk about, but now that we've laid the groundwork of what a game engine is, what game engines can do, we'll start looking at what people have done with it. What have they done with these game engines, and where did it take us that we couldn't have gotten to if you hadn't started with a game engine and tried to start from scratch. All right. Thank you. Have a good time, and I'll see you next week. Bye.